Right. Good morning. We're going to, as I said, I posted the solutions to that question 8 and question 9 earlier this morning. So hopefully you've had a chance, and if you haven't had a chance, please go and have a look at that. The questions weren't that difficult. As I said, the most difficult part there is getting through all the English to be able to get to the maths. Okay. Right. Let's move on, and we're actually going to be doing the last thing in this section today. So this is kind of a wrap up of the section. I'd like to do a bit of a quiz next week. Okay, it's not an actual test as such, but it'll just be a quiz, and I urge you guys to do the quiz with a little bit of self-discipline and not have sort of WhatsApp communications and asking everybody. Okay, so I think we'll buy ourselves some time and we can do it on Friday next week. It'll be a little bit of a quiz, and we'll take it from there. So I was going to do some past paper questions tomorrow. I will still post those tomorrow, but we'll only go through them as a class on Monday. But Simo, that is actually a really good idea, Mago. Okay, let's try that. Okay, we'll do a test run on Wednesday, just a little mini one on Wednesday, and then on Friday we'll do the official one for marks. Okay, so basically Monday, Wednesday, Thursday we're going to do as a consolidation. Hey Roman, a Kahoot is far more exciting than a Google quiz. So maths, it won't be formal assessment, if I can put it like that. Okay, it'll be an assessment for me to gauge whether you are, or how you've understood the section, how you've coped with the section. I won't be able to use the marks for any reports or anything else like that, but who knows how we're going to do reports. But yeah, okay, let's just, for the meantime, make the best of the situation and give it our best. Okay, so I'm going to go into presentation mode. I know some of you are battling with your microphones at the moment. So if you have got a question, just type it up. And once I'm finished my presentation, then I will answer your questions. Right. So let's have a look at our last part of the section, and that is sigma notation. Now, sigma notation, I think everybody knows what I say about mathematicians. They are the laziest people in the world. And if we can find a shorter way of doing something, we're going to. And if we can't find a shorter way of doing it, we will invent one. So sigma notation is one of those notations that we've invented, or not we, mathematicians have invented to be able to write something in a shorter way. So let's have a look at what the symbols are and what it looks like. Some of you may have seen this already. Some of you have looked on your calculators and perhaps played with it a bit, right? But it's a symbolic representation of a series. So this funny looking thing that you see on the screen over here actually represents an entire series. Okay, so let's have a look and see what the different parts of that notation actually represent. So first of all, that big funny symbol there, and that big funny looking E or 3 or backwards 3 or whatever is actually called sigma. Okay, and all it means is find the sum. So that just replaces a whole bunch of addition signs between terms. Okay. That TK, we've seen it before. We've seen it TN maybe, all right? And that is the general term of the series. Now, guys, you need to understand that this TK can have any formula whatsoever. And we're going to have a look at a couple others as we go through this presentation. Okay, so TK just represents, it's a formula for the general term. K equals P. So now the P will be a number. So when you see this, it'll actually be a number, 3 or 7 or 1 or whatever. And that simply just means that's the first number you're going to replace NK in the formula. And that will give you your first term in that formula. We'll talk about that a little bit more just now. And that N at the top over there will also be a number. It can be an N, and we're going to have a look at an example just now where it's an N. And it'll make sense in the question. That is the position of the last term that's got to be added, or the last value that we're going to replace K with. So it stands to reason that N and P are both numbers. Okay, let's have a look at that example there. All right, this is just an example of what this means. So let's go through it. This funny little symbol, the sigma sign, this represents or tells us we need to be adding all the terms. This tells me here how each term is generated. So that's a formula to generate the terms. In this case, the formula is 15 minus 7n. N equals 1 tells me that when I start my series, the first number that I need to put in the place of n is 1. And I need to go all the way until n equals 5. Right. So this is what's been generated by doing that. So when I replace n with 1, so I'm putting 1 in the place of n, I get 15 minus 7, and that gives me 8. When I replace n with 2, I get 15 minus 7 times 2, which is 1, and that's my second term in the series. When I replace n with 3, I get 15 minus 7 times 3, which is negative 6. And I continue that, so replace with 4, and then I replace with 5. Okay, so that's how I can generate the series, by doing substitution. This is actually quite an easy one. I've only got 5 terms in the series, so it's not that difficult to actually write out. You guys are going to get some practice just now in order to get into the habit of what this is actually doing. So don't panic too much about that. All right, let's have a look at that example. Expand n equals 1 to 7. That dot there, guys, I need to emphasize, because it happens across the school and across the country, where a number of people get confused with that dot there. In South Africa, we use a dot for multiplication. We use a comma to signify a decimal. So while the rest of the world is using a dot to signify the decimal, South Africa still uses a comma. Okay, so this dot here actually represents multiply. So please don't get confused. This is not 3 comma 2 to the power of n minus 1. It is 3 multiplied by 2 to the n minus 1. Yes, Matt?
So, isn't it technically supposed to be in the middle of the text though, as well? Like it's supposed to be not at the bottom, like in the middle?
The what, sorry?
The dot, isn't it supposed to be in the middle? Like, I know you can't show it in the example here, but isn't the multiplication dot supposed to actually be in the middle?
That's what the rest of the world actually does as well. That is because they use the point as a decimal. So they use the dot as a decimal. So to make sure people don't get confused between the two, the dot actually goes between there in the rest of the world.
Oh, I see. Yeah.
Okay. South Africa just do it with a comma, and then the dot down the bottom is actually not confused with that. Or supposedly not confused.
Yes, sir.
Okay, guys, I'm going to give you a little bit of time to actually generate that and see if you can come up with that. And while you're busy doing that, I'm just going to switch between my tabs, and hopefully you can now see my whiteboard. Okay, guys, are we ready? We're going to generate the series by replacing this n in my formula, because remember, this part over here is my formula. So that is actually, in this case, it's Tn. Yeah, so that's the formula to generate the terms. Okay, so if I replace 1 there, or I replace n with 1, this becomes 3 times 2 to the 0, which is 1. So my first term is simply 3. My second term, remember the plus sign because we're dealing with sigma, and sigma tells me we are adding. So now replacing the n with a 2, we get 3 times 2 to the 2 minus 1, which gives me an answer of 6. Then I replace n with 3. 3 times 2 to the 3 minus 1, I get 12. Now, if I carry on this series, I've got to carry on all the way until n is 7. So I get plus 24 plus 48. I'm going to run out of space here. Plus 96 and plus 192. So if I just write this all closer together, this sigma notation is 3 plus 6 plus 12 plus 24 plus 48 plus 96 plus 192. Okay. Right, hopefully you guys were all able to get that. It's not a horribly difficult one. Okay, let's now have a look at the difference. In this example 2, I don't say expand. The word used here is evaluate. And I'm asking you to evaluate that horrible looking thing. What do you think the difference is between the two questions? What is the difference between evaluate and expand?
So,
yes.
So I would say that expand would be to give each term in the series, whereas evaluate would be to calculate the sum of all of the terms up till the 10th term.
Absolutely perfect. Absolutely correct. So expand just means give the terms. Evaluate means possibly give all the terms and add them up to get an answer. Okay, so here we're looking at a Tn, that is different to what we've had a look in the rest of our sequences and series. Okay. So if we come back to my whiteboard here, notice t now starts at 3, which means the first number we replace t with is 3. So if we replace t with 3, okay, we get 9 minus 18. So my first term is minus 9. Then t becomes 4, 16 minus 24. And that gives me minus 8. Then t becomes 5. 25 minus 30 is 5. 36 minus 36 is 0. 7, 49 minus 42 is 7. 8, 64 minus 68, I think that's 16. 9 is 81 minus 54, and I think that's 27. And the last one is 100 minus 60 is 40. So in this particular case, we actually have to expand the series before we can add it. Okay, so that's minus 17, minus 22, minus 15, plus 1, plus 28. So our final answer here should be 68. Okay. Now, those of you who have the Silver Casio, you can do this on the calculator. Okay. So a question this simple is not something that's going to appear in a test or an exam. But it is fundamental to you to be able to understand this process and to know what you're actually doing. Right. So the 2 exercises you're going to do today are going to be based on that. And as I said, it's important that you're able to understand this concept. Okay, so we've done that example. Let's have a look a bit more at what we're talking about here. Okay, so in this thing, we've seen this thing now, we're acquainted with it, and I do apologize, there should be a TK there. P is a natural number, we've spoken about that because we have to count up in ones here. Okay, TP, in other words, whatever the first value is that we've got to replace K with, is actually the first term of the series. We've seen that in this previous example where we had to replace T with 3 to start off with. The number of terms in the series is that top number minus the bottom number, and then we just got to add 1. And this kind of actually stands to reason that your top number has to be bigger than your bottom number. Right, let's have a look at a different type of question now. And this question, as I said to you when I was introducing the notation, they don't have to give us a value for n. In other words, they don't have to give us that little top number. In this case, they haven't. All they've given us is the starting value of k as 1. They've left us unknown at the top, but they have given us a formula. But there's more that they've given us in this question. In this question, they've actually told me that the answer here is negative 1,587. Okay. So in this question, they're actually asking us to determine the value of n. So they're actually asking us how many terms are added together here. So let's go back to my whiteboard. Okay, and there I've got the question. So if we expand the left-hand side here, we're going to get, I'm just working with the left-hand side. When I put k as 1, I get 8. When I get k as 2, we get 1. And we've seen this series. It's actually one of the examples that we did earlier. It's the actual expanding one. When it's 3, I get -6. Hopefully by now you've actually seen a pattern. In fact, even just by looking at my formula over here, we should be able to identify and recognize that this is an arithmetic series. This is linear, okay? It has a power of 1. This looks something like our mx plus c, which means my series is linear, and we've learned that linear series this year we're going to call arithmetic series. So this is an arithmetic series. Right, it's an arithmetic series with a equal to 8 and d equal to -7. Are you happy with that? Right, we could have carried on the series and made sure that the pattern was like that, but our formula over here gives it away. If this was exponential, then that would have meant we had a geometric series. Okay. So what does this actually mean? How does it help us to know that we're dealing with an arithmetic series? Well, remember, this sigma notation tells us we're looking for a sum. So if I know that I'm dealing with an arithmetic series, I've got a formula for the sum of n terms. And that's that thing there. So if that's my formula for the sum of n terms, I know what a is, I know what d is, n is the unknown, but I do know what the actual answer is when I substitute a and d. So I can then say n over 2 times 8 plus n minus 1 times -7 is equal to -1587. And now I've got an equation where there's only n that's missing, and I can solve this equation. We know this is going to be a quadratic equation. We've done examples like this, or quite a lot of them. So I'm going to get rid of the division by 2 first, and simplify inside the brackets. I think I've got that multiplication right. This becomes 23. So actually I've got -7n squared plus 23n plus 3,174 equals 0. That equation is far too complex for me to even try and think about factors, but because it's a quadratic equation, I can make use of the quadratic formula. So n is equal to -23 plus minus the square root of -7, sorry, that's horrible, of 23 squared minus 4 times -7 times big number. Now you're just going to plug that value into your calculator. Or you're going to plug that. We're going to start with the plus. Obviously, we can't do both on the calculator. Minus 4, negative 7, 7, 4, all over negative 14. And there we get an answer. N is equal to negative 138 over 7. Or we're now going to go back and change our plus into a minus. And there we get an answer of 23. Right, so now we get two answers for n. However, that one there is not applicable. And we've done enough of these by now to know that my n value, because I'm dealing with n as a term position, my n value cannot be negative to start off with, and it cannot be a fraction in the second instance. Right. Any questions, guys?
So if that positive number was a decimal or had a decimal place, would you round up or would you? Because I remember something in the past where we was rounding up. Like if it was 22.94, would you just round it up to 23 or would you leave it as 22?
Just a couple of ways there. You would round down if that was necessary. So that the only time that you would do that is when they would say to you, what is the first term, or how many terms will first exceed, or how many terms, the sum of how many terms will be below a certain number. That's when we do the rounding. In this case, if they're asking you to determine an actual value for n that is equal to that, okay, if you do not get a whole number, then there's two possibilities. One, you've made a mistake somewhere, and I would go back and I would check my working. Secondly, the answer would then become there are no terms that would give that exact answer. I hope that answered your question.
So basically, if you get a decimal place, then you've done something wrong.
If it's given to you as an equal sign, yes. Okay, next, we will go through next week and have a look at those type of questions where they say to you, what is, how many terms, the sum of how many terms will first exceed a value or be minimum, be less than a value. We will have a look at examples like that, but I want you guys to get the fundamentals here first, please. So the work that I've assigned to you in the textbook is just expanding, getting to know the formula and how it works, okay? And then the second part of it is the evaluation. Okay, so next week we'll have a look at questions like question 5 that says, what is the greatest number of terms for which? And then, and least number of terms. So we'll have a look at those examples next week, but I just want you this weekend, today or whatever, to get to grips with working with sigma notation. And that is that question 3 and question 4 of exercise 1.7. I'm going to stop presenting. That just means you Any other questions, guys? Right, I'm done for the lesson then. You guys can either stay on the line for the next couple of minutes and ask questions if you come across any difficulties, or you're welcome to leave and go on to the next lesson. It's an absolute pleasure, guys. Enjoy your long weekend. Enjoy being able to get takeaways this weekend. Yes, Roman, it's only question 3 and 4 of 1.7. Thanks, Roman. You too. Have a good weekend, guys. Enjoy sleeping in tomorrow.